In this lesson, we are going to find the area between a straight line and a curve. In order to find the area, we will use the definite integral of the upper curve minus the definite integral of the lower curve. Take note that the upper limits and the lower limits of two curves must be the same. Let's look at this example here. The upper curve will be the straight line y equals to 5 minus 2x, and the lower curve will be the curve y equals to x squared plus 2. So what is the upper limit and the lower limit? In order to do that, we must solve the simultaneous equation here. Upon solving the simultaneous equation, we will realize that this point of intersection will be x equals to 1, and the second point of intersection between the two curves will be x equals to negative 3. So why do we use the top curve to minus the bottom curve? In this case here, if we find the definite integral of the straight line, which is from 1 to negative 3, 5 minus 2x with respect to x, we will be getting the area of the trapezium A, B, C, and D. When we find the definite integral bounded by the same upper and lower limits from 1 to negative 3 for the curve y equals to x squared plus 2, we will be finding the area by this shaded region in pencil. So in order to find the red shaded region, we will need to use the trapezium minus the pencil shaded area here, which is why we need to take the top curve, which is a straight line in this case, to minus the bottom curve, which area will be represented by the pencil shaded region. Another way of writing this is that we can combine these two definite integral because they have the same upper and lower limits. So what I will need to do is I will have 5 minus 2x minus, remember to put a bracket, x squared plus 2 with respect to x. Simplifying it, we will have 3 minus 2x minus x squared dx. So if we integrate now, we will get 3x minus x squared minus x cubed over 3. The upper limit will be 1 and the lower limit will be negative 3. If we substitute in 1, we will have 3 minus 1 minus 1/3. If we substitute in negative 3, we will have negative 9 minus 9 minus negative 27 over 3. And we will subtract these two values here. That will give us the area 10 and 2/3 square units. Okay, next, let us look at this case. We have the curve x squared minus 3x minus 10 and the straight line 3x minus y minus 19. In order to find the red shaded area, we will take the top curve minus the lower curve. So the lower curve in this case will be the straight line. So if we do the simultaneous equation, we will realize that this point of intersection is 3, negative 10. So the area bounded by the top curve from 0 to x equals to 3 will be this region A here, which is given by the shaded pencil region. The area bounded by the bottom curve will be the trapezium A, B, C, D. So once again, we realize that the area of the top curve and the area of the bottom curve have the same upper limit, which is 3. And therefore, we can simply use the definite integral from 3 to 0 of the top curve, which is x squared minus 3x minus 10, to subtract the bottom curve, which is the straight line. And if we make y the subject, it will be y equals to 3x minus 19. So we will minus the bottom curve. Remember to put the bracket, 3x minus 19. So we'll use the equation of the top curve to subtract the equation of the bottom curve. And this will work only if the upper limit and the lower limit of the two curves are the same. And this will simplify to x squared minus 6x plus 9. If we integrate this, we will have x cubed over 3 minus 3x squared plus 9x from 3 to 0, which will give us the answer of 9 square units. The first case, both curves are above the x-axis. For the second case, both curves are below the x-axis. So it does not matter whether it's above the x-axis or below the x-axis. All you need to do is take the equation of the top curve to subtract the equation of the bottom curve and make sure that they are bounded by the same upper and lower limits. Now let's look at a different example here. These intersection points using simultaneous equation will be 3, 11. If we solve y equals to x squared plus 2 and y plus 2x equals to 17 simultaneously, it will give us this intersection point. If we find the area bounded by the curve and the points from 0 to 3, it will give us this region A on the left of the dotted lines. So how then do we find the whole shaded region here? We must also find the region B. So you realize that region B is actually a right-angled triangle. So let us find this point here. In order to find this point, all we need to do is let y be 0 in order to find this x value here, and that will give us 8.5. So with this x value of 3 and 8.5 and the y value of 11 here, later we'll be able to find the area of this triangle. So let's find the region A and region B separately now. To find region A, we need to find the definite integral. So area of A is equals to the definite integral from 3 to 0. And the equation is x squared plus 2 dx. So we will have x cubed over 3 plus 2x from 3 to 0, which will give us 15 square units. Next, we need to find the area of region B. So area of region B is fairly straightforward. Okay, we will need to find the area of the triangle using half. The length of the base will be 5.5 times the perpendicular height, which is 11. This will give us the value of 30.25. So to find the whole red shaded region here, all we need to do is use the area of A and we add to the area of B. So the area of the shaded region will be equals to 15 plus 30.25, and that will give us 45.25 square units. Now, why can't we use the previous method just now? If we use the previous method, area of the top curve minus area of the bottom curve will actually give us this blue shaded region. Let's call this region C here. Now we are not looking for region C. We are actually looking for region A plus region B. So we could not use the previous method. So we are asked to find the area of this red shaded region here. So you realize that if we use the area of this big triangle here and subtract this region A, we will get the red shaded area. So how do we get the area of the big right angle triangle? In order to do so, we need to find all these intersection points. So to get these 2 points, we will let x be 0. So when x is 0, the value of y is -2. By substituting 0 into the equation, x minus y minus 2 equals to 0. In order to find this intersection point with the x-axis, we let y be equals to 0. And that will give us x equals to 2. So now we can easily find the area half times base times height. To find the area of region A here, okay, I will now shade it using a pencil. I will need to find this intersection point of the curve e power x minus 3 with the x-axis. In order to do that, I will let y be equals to 0. So solving it, I will get this x value to be ln 3. So now let's find the area of the triangle first, which is a fairly easy task. So area of the triangle will be half times 2 times 2. And that will simply be 2 square units. To find the area of the region A, we will need to integrate e power x minus 3 dx from ln 3 to 0. Now, do take note that this area here is below the x-axis. So if you just do like this, you realize you will get a negative area later. So in case you get a negative area later, remember to put a negative signs to convert it to positive. So for now, let's put a negative sign first, since we are already expecting a negative area later. So when we integrate, we will get e power x minus 3x from ln 3 to 0. And we will consistently put a negative in front. Now once again, remember we still need the negative sign and do put a bracket. And this area, if we press the calculator, we should get 1.2958. So finally, what should we do with these two areas here? Yes, we should take the area of the triangle to subtract the area of region A. So finally, the area of the shaded region will be equals to area of the triangle, which is 2, and we will subtract the area of region A, which is 1.2958. And this will give us 0.704 square units. So how do we solve a question like this? First region, let's call this region A. I will take the top curve minus the bottom curve. And in order to find this region B here, I will take the top curve minus the bottom curve. You will also realize that in order to do that, I must be able to find all these intersection points. So if I solve these two equations simultaneously, I will get this point as -2, -3. I'll get the second intersection point as -1, -2, and the last intersection point will be 1, 0. As the top curve and the bottom curve is bounded by the same upper and lower limits, I can simply use the first method that we learned just now, okay, which is to find the area of region A. I will take the upper limits from -1 to -2. And I'll take the top curve, which is x cubed plus 2x squared minus 3. I will subtract the bottom curve, which is the straight line x minus 1. Please remember to put a bracket. Okay, otherwise your last value will not be correct. So simplifying it, we will have x cubed plus 2x squared minus x. So we have minus 3 plus 1, which is minus 2 dx. Integrating it, we will have x power 4 over 4 plus 2x cubed over 3 minus x squared over 2 minus 2x from -1 to -2. That will give us 5 over 12 for region A. Now let's find region B here. So we will take the upper limits from 1 to -1, and we will take the top curve, which is x minus 1, and we'll subtract the equation of the bottom curve, which is x cubed plus 2x squared minus 3. And once again, remember to put the brackets. Simplifying it, I will have negative x cubed minus 2x squared plus x plus 2. So if we integrate it, we'll get negative x power 4 over 4 minus 2x cubed over 3 plus x squared over 2 plus 2x from 1 to -1, which will give us 8 over 3. So to find the shaded area, we will need to add area of A with area of B. So that will be 5 over 12 plus 8 over 3, which will give us 3 and 1 over 12 square units. And that's the end for this topic.